Okay, good day again, students. For the continuation ng series natin para sa electrical system, this will be the part 2. So tapos na tayo sa ating guidelines from the previous video. Today, for now, sample na tayo ng simple lighting outlet plan or yung kanyang computations. So we have here a sample ng lighting plan. So single family dwelling, yung type of service natin, meron tayo ditong 230 volts. And then single phase, meron siyang kumbaga 2-wire of 60 Hertz or yung ating 60 degrees Celsius maximum temperature na capable or 60 degrees Celsius yung kayang temperature ng ating wire na gagamitin. Okay? So, here, lighting plan lang muna ang ating consider. So, we have a lighting plan, and then we have the condition or problem. A single family dwelling is to be circuited with the following requirements na nandito sa ating figure. Determine the size ng ating branch circuit wire for the lighting outlets. Letter B, size ng ating conduit pipes. And then letter C is yung size or rating ng ating fuse or yung ating overcurrent protective device. So sa solution, kumbaga isang circuit lang yung ating consider dito sa ating dwelling unit dahil maliit lang naman ang kanyang lighting system. Okay, so from the figure, we will determine the number of lighting outlets. So by direct counting, meron tayong 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so we have a total of, by direct counting, we have again 1, 2, 3, 4, 5, 6, 7, and 8. So we have a total of 8 lighting outlets. So from the National Electrical Code, it provides that 100 watts shall be the maximum load for each household lighting outlet. So yung ating number of outlets, ito times natin siya sa 100 watts para makuha natin yung ating outlet loads or yung ating circuit load. So meron tayong total na 800 watts for this circuit number 1, yung kanyang lighting load. Step number 2, determine natin yung ating total current load. So to have our total current load, i-divide natin yung total load sa ating type of service, which is 230 volts. So we have a value of 3.48 amperes for our current load. Step number 3, determine natin yung ating size of conductor wire. Okay, so magre-refer tayo sa ating table 2-5 or table 4-2, which is present dito sa ating PowerPoint. So, gimension ko na present dito sa ating PowerPoint kasi ibibigay ko din itong PowerPoint natin para sa maano ninyo, students. Mas review ninyo kumbaga. So, balikan natin itong number 2. So, meron tayong na-compute na total current load na 3.48. So, kung isipin natin, ito lang yung current load ng ating circuit number 1. So, ano ba yung minimum market size, kumbaga, or minimum market available sa market na amperes para sa ating overcurrent protective device or yung ating fuse or yung ating breaker. Yung ating fuse. So, yung 3.48, mapufall siya sa 15 amperes, which is, nandun na din sa na-mention natin dun sa ating circuiting guidelines kanina, di ba? 15 amperes yung minimum na gagamitin. So, kahit na maliit yung ating na-compute na load, diretso na siya mag-fall doon sa ating minimum specifications. So yung ating 15 amperes, ang partner niya is kung 15 amperes ang ating gagamitin na fuse, ang kanyang wire, minimum wire is 2.0 mm squared, or yung ating number 14 copper wire. Again, yung TW is kind of wire yan siya. So nasa designer na ang discretion kung anong material ang gagamitin. Okay? So here, we will determine yung ating size ng wire and then yung ating overcurrent protective device or yung ating fuse, which is dahil sa ating total current load na na-compute na 3.48, mag-fall na siya sa ating minimum na 15 amperes. Then, yung kung ang partner, kung 15 amperes ang ating fuse, ang kanyang wire is number 14 copper wire. Okay? Next, determine natin yung size ng ating conduit pipe. So let's proceed sa ating table 2-9. So here we have our table 2-9, maximum number of wires in a conduit. So we have here sa ating, here is yung ating size of wire. So meron tayong number 14, which is yung 2.0 mm. Yung ating 12, number 12, 3.5 mm. Number 10, 5.5 mm. And number 8, which is yung 8.0 mm squared na copper wire. So since yung ating gina-consider sa ating linya ng kuryente is dalawang wire yan siya in every conduit or yung pipe natin. Kasi, bakit dalawa? Meron kasi tayong live wire and ground wire. So dito na tayo magpo-focus sa ito lang kasi yung mga conditions lang ito. Kung mas complex na yung inyong matutunan sa sunod, yes, magagamit yun na itong ibang conditions na ito. Pero since yung ating gina-consider dito sa ating family dwelling unit is just simple wiring system. So dito na tayo mag-focus sa number 2 pieces of wires per conduit. So since yung ating wire is number 14, okay, number 14 or yung 2.0, yung ating conduit size is mag-fall sa 13 mm. 13 mm na size ng conduit or 1/2 inch diameter PVC pipe ng ating conduit. Okay. So again, the size of our conduit pipe is therefore specify 13 mm diameter conduit pipe. And then again, yung ating size or rating ng ating fuse is 15 amperes, which is yung minimum para sa ating lighting layout plan. So dito nagtatapos yung ating simple illustration para sa ating lighting plan. Next is para sa ating convenience outlet plan. So here, ito ang ating sample para sa ating convenience outlet layout plan. So babasahin muna natin yung comment from NEC or yung code from NEC. The ampacity of a connected load shall not exceed 80% of the amperage capacity of the conductor and the fuse. In table kanina na 2-5 and 4-2, the maximum ampacity load ng 2.0 mm diameter or number 14 na copper wire is 15 amperes, which is galing din sa ating circuiting guidelines. And 80% of the 15 amperes is 12 amperes, which is the maximum load na makukonsider of the circuit sufficiency enough to carry yung ating computed na 3.48 amperes. For maximum 100 watts per lighting outlet. Therefore, again, we will use number 14 wire. Kasi safe din siya sa ating computation. So, okay, proceed tayo sa ating next plan, which is yung ating convenience outlet layout. So we have the plan layout here, floor plan niya. So meron tayong comment from NEC provides that for each single receptacle shall be considered no less than 180 watts rating. It is simply mean that each convenience outlet is considered to have a maximum load of not less than 180 watts per gang or yung ating per plug. So ginamin dyan, kumbaga itong ating convenience outlet, example may 2 gang tayo. Ayan, 2 gang. Kumbaga 2 saksakan per outlet. Each saksakan is kukonsider tayo na maximum load na 180 watts. So 180 watts ito, and then dito 180 watts din. So for this outlet, meron tayong 360. Okay? Okay, diretso na tayo sa, proceed tayo again sa ating computation. So from this figure sa ating layout plan, erase ko muna ito siya para hindi madumi. Okay? So, there are 6 convenience receptacles for the small appliance load. Kasi, except dito sa ating kitchen na 2, tatlong gang siguro ito siya. 2 gang lang muna ating consider. So, 2 gang natin is 1, 2, 3, 4, 5, and 6. So meron tayong total of 6 convenience receptacle for small appliance load. So considering that there are 2 plug per outlet, which is considered dito 2. So 6 outlets times 2 plugs. So meron tayong 12 pieces. Itong pieces na ito, times natin again doon sa ating 100 watts rating. So for the total estimated load for our convenience outlet, we have 2,160 watts. So determine natin ang kanyang current load. I-divide na natin siya sa ating type of service for this particular sample, 30 ang ginamit. So may value tayo na 9.39 amperes for the value ng current load niya. So 9.38 amperes. And again, balik tayo dun sa ating circuiting guidelines. Di ba ang sabi doon, pag once ang ating gina-consider is convenience outlet, ang ating minimum fuse is 20 amperes. So, yung computation natin is minimum sa 20 amperes, di ba? Pero since ang gina-compute natin is ang convenience outlet layout, ang ating amperage for this is, or yung amperage ng ating fuse is 20 amperes. So here, 20 amperes. No, kahit na, di ba, sabi doon din again sa ating guidelines na 80% lang ng ating fuse ang gagamitin. So yung 80% niya is 16 amperes. So maximum pa rin siya or malaki pa rin siya kaysa dun sa ating na-compute. Pero dahil na-specify sa NEC, yun pa rin ating gagamitin, 20 amperes. Okay? So yung 20 amperes natin, from table 4-2, punta tayo doon. Okay? Dito, itong 60, yung ating i-consider dito sa ating problem, which is ang pinaka-economical, kumbaga, pinakamura sa market. Okay, so yung ating fuse sa ating circuit na gina-compute kanina is 20 amperes. Ang kanyang size ng wire is 3.5. Okay, or number 12 na copper wire. So here, para sa size ng ating conductor wire, we will use the 2 pieces of 3.5 or number 12 copper wire. Again, bakit 2 pieces? Kasi gagamit tayo para sa live wire and ground wire. Kaya use 2 pieces of 3.5 or number 12 copper wire. And then, ano ang size sa ating conduit pipe? So, punta tayo sa table 2-9. So, since dalawang wire, di ba? Okay, para dun sa ating ground wire and live wire. So, ito yung consider natin. Dalawa. Tapos, ano ba yung ating wire? Di ba? Ang size niya, 12. So, fall siya dito sa ating safe siya na ma-accommodate ng 13 mm diameter na conduit pipe. So, ang ating gagamitin is 13 mm. So here, we will use 13 mm conduit pipe. Okay? So next, yung ating comments from NEC. On convenience outlet receptacle, the NEC provides that each single receptacle shall be considered at no less than 180 watts rating. Number 2, examining the values na na-compute natin. And from the table 4-2, number 14, copper wire has an allowable ampacity rating of 15 amperes, di ba? Granting that only 80% ng 15 amperes ang makonsidered, yung the rated value is still 12 amperes. It is very larger than dun sa na-compute natin na 9.36. Para dun sa 6 convenience outlet with 2 gang. Pero, since specify ng ating NEC na ang gagamitin pag convenience or power line layout ang gina-consider is ang minimum fuse rating is 20 amperes. Okay? Although 2.0 or number 14 conductor wire, it could safely carry the 9.36 computed load. Considering 15 amperes ampacity rating, yet we cannot do so because the code specifically mandated that the use of 3.5 mm or number 12 copper wire as the minimum size for all types of convenience outlet wiring system. Yan na yung pinaka redundant. Yan na yung minimum para sa ating convenience outlet wiring. So, for appliance limited load wherein 2.0 or 14 wire is, wait lang. A minimum for all types of convenience outlet wiring except for mga appliance na minimum masyado ang load. Pero para safe na, kasi hindi natin alam, kumbaga ma-anticipate na sa future na makabili kayo ng appliance na mataas yung kanyang load rating. So, para safe na, dun na kayo sa minimum na 3.5. Okay, next is, dun na tayo sa other loads. Kumbaga, dun na dito. Redundant masyado. Dito na tayo sa kitchen, kumbaga, yung mga appliances na nasa kitchen. So, for other loads, we will consider or assume meron tayong electric stove with the appliance rating na 1.1 kilowatts or 1,100 watts and water heater na 2.5 kilowatts or 2,500 watts. So may total load tayo na 3,600 watts. So total load na yon, kukunin natin ang kanyang current load. So divide natin sa total service 230, we will have value of 15.65 amperes. Okay. Next, i-determine natin yung size of the conductor wire. So, punta tayo sa 2-5. Okay, sa table 2-5. So, yung ating computation is 15.9 something ba yun? Nakalimutan ko. So, mapupall siya dito sa ating 20. Diba? 20 amperes na fuse. And then, diba, ang ating fuse dapat 80% lang yung mga gamit. So, ang 80% ng 20 is 16. So, mapupong pa rin siya doon na value. So, for that, 20 amperes ang gagamitin natin, yung wire niya is 3.5. So balik tayo dun sa ating problem. So for the 15.65 amperes load, we will use 3.5 or number 12 na copper wire. Then, again, sa mga na-compute natin kanina, yung safe na size ng conduit pipe niya is 13 mm diameter. And then, yung ating fuse, size ng fuse natin or rating ng fuse natin is 20 amperes. Sa 20 amperes na yan, ang gagamitin is 16, di ba? So, mag-fall pa rin siya dito, pero borderline na. Okay. So, yung comment ng ating NEC, the fuse rating is 20 amperes, granting that it will be derated again sa derated ng 80%, which is meron tayong 16 amperes derated value, is still higher, pero borderline na nga, dun sa ating computed load na 15.65. Pero, therefore, the 20 amperes fuse over current protection is accepted. Next, we will find the size of the service entrance. Wait lang. The size of the service entrance being the supply conductor and equipment for delivering energy from the electricity supply to the wiring system of the building is also computed based on the total load supplied by the branch circuit. Continuing the solution, we will have the following. So, i-compute natin yung total load from circuit 1 to circuit 3. So, we have 800 watts plus 2,160 watts plus 3,600 watts. Divide natin sa type of service, which is 230 volts. We will have a value of 28.52 amperes. And we will apply 80% demand factor as permitted doon sa ating NEC. Considering this is a non-continuous load. So, yung ating 28.52 times sa 0.8, we will have a value of 22.8 amperes. Next, we will find the size of the service wire. So, re-refer tayo dun sa ating table 2-5 again. Okay, so yung ating computation is 22 point something nga. Pero, mapapall siya dito sa 30. So, ang gagamitin is 5.5 or number 10. Pero may comment ang NEC regarding dyan. So, let's read the comment. So, here, yung ating size ng ating wire from the total computed load na 22.8, we'll use, di ba nakita natin doon, number 10, copper wire. Pero we will use 8.0 mm or number 8 copper wire. We will read the comment ng NEC later. And then yung size ng conduit pipe for this service wire from the table 2-9. So let's see, number 8 number 8 na wire. So number 8 na wire, and then two wires per conduit, doon siya mag-fall sa 20 mm diameter conduit pipe. Okay. Okay, so yun nga, we will use 20 mm diameter conduit pipe. So itong figure na to is a one-line diagram. So before we proceed here, we will read the NEC comments. So number one, we have a demand factor of 80% was applied considering not all receptacles and outlets are being used simultaneously. Okay, from 28.52 times natin siya ng 80%, we will have a value of 22.8 dahil dyan. Dahil sa comment na ito. Number two, these types of loads are classified as non-continuous loads. So from table 4-2, yung ating dapat, 'di ba kanina nakita natin 5.5 mm or number 10 na copper wire ang ma-fall sa 30 amperes, which is bigger dun sa ating 22.8 amperes na compute. However, we cannot do that kasi not specify the use of 10 wire, number 10 na wire, because the code limits the use of 8.0 mm or number 8 na copper wire or conduit wire as the conductor as the minimum size of the service entrance. So, kahit na maliit yung computation natin, since yung minimum size of service entrance is number 8 conductor wire. Number 3, the National Electrical Code on Service Entrance provides that service entrance shall have sufficient capacity to carry the building load. They shall have an adequate mechanical strength and shall not be smaller than 8.0 mm or 3.2 mm diameter, except for installation to supply limited loads of a single branch circuit, such as small polyphase power, controlled water heaters, and like, and they shall not be smaller than 3.5 mm or 2.0 mm diameter, copper or equivalent. Or para mas safe, gamitin na talaga natin yung minimum na 8.0 mm or number 8 na conductor wire. So, next is yung ating main disconnecting means or yung ating safety switch. Find the total computed load. So, yung ating mga current load. So, may total tayo na 28.52 amperes. Okay, so yung total computed load natin is 28.52 amperes. And then yung gagamitin natin na service entrance wire is 8.0 or number 8 na conductor wire. And then magpo-fall yung conductor wire natin sa 40 amperes, di ba? So, balik tayo dun sa table. Okay, so ito, di ba, number 8 yung service entrance wire natin. So, fall siya sa 40 amperes. And then, nasa code natin na hindi tayo kung 40 amperes, hindi din yun ang gagamitin natin. Diba? Ay, kumbaga, dun sa ating main breaker, dapat yung maximum is, maximum the rated value niya is 40. So, yung 40 na yan, 2/3 value yan siya. So, balik kayo doon sa ating circuiting guidelines number 3, number 2 and 3, and 4. So balikan nyo doon. So yung kung 2/3 value natin ang 40, ano ang kanyang whole amperage fuse? So 2/3 dapat ano comment? 6. So 40, 60 amp yung ating gagamitin para sa main breaker. So, we will use two 30 amperes fuse parallel connection na magiging 60 amperes to pole single throw or yung ating PST, 250 volts safety switch. So, kahit na yung ating voltage is 220 to 230, yung ating safety switch is meron siyang safe factor of safety na kahit na mag-fluctuate larger than 230 yung ating voltage drop, is yung ating safety switch is safe pa rin kasi ang kanyang voltage na ina-anticipate is up to 250 volts. Okay, number 3, provide 2 double branch circuit cutout with 2 15 and 2 20 amperes fuse respectively. So balikan natin yung ating one-line diagram. So ito ang ating one-line diagram. So this is our one-line diagram. So dun sa ating circuit number 1, dun sa ating lighting outlet, 15 amperes. Dun sa ating circuit number 2, yung ating convenience outlet is 20 amperes. Doon sa ating kitchen other loads, yung water heater, and etc. 20 amperes ang kanyang computation. And para sa ating spare, bibigay tayo ng anticipated na 15 amperes. So that is our one-line diagram. For our multi-ground system and line-to-line service, the protection of branch circuit is tapped to the hot line or yung ating live wire. The ground line being neutral, zero voltage, is not protected with fuse. This is one advantage sa ating multi-ground system being adopted by the electric cooperative implemented by the Rural Electrification Program of the government. The branch circuit and cut-out could be doubled because the engaged voltage in the line is only 230 volts, while the other is zero voltage, being grounded. So other electric service system, on the other hand, is classified as the line-to-line service, which is wherein the engaged voltage is 115 to 230 volts, which requires fuse protection for both lines. So since natapos na tayo sa ating computation, we can have the schedule of loads. So yung ating number of circuits is 3, pero bibigay tayo ng spare, so meron tayong 4. Sa load, we will put this yung ating mga description ng ating circuit number. Ano yung loads doon sa ating number. So light loads, number 1. Small loads, power line layout sa circuit number 2. And then same as circuit number 3, pero other loads na ang kanyang destination. So 4 is spare. So number of outlets, 7.8, the light load, small appliance, 6 convenience outlet, 2 gang. And then yung other loads. And then yung volts na specify natin is 230, 230, 230. Pero again, dun sa gagamitin niyo sa inyong computation, mas safe kung 220 para medyo magtaas yung kanyang current load. So mas malaki yung kumbaga factor of safety ninyo. So here, input nyo lang yung mga sa ating computation. So meron kang watts, yung total load mo, yung ampere or yung current load mo. Yung current load mo is from watts divided voltage. Yun yung ampere mo na gagamitin. Yung number of pole natin, 2-phase tayo ha. 2-phase. Lahat na yung 2-phase. Kasi meron tayong live load and ground, live wire and ground wire. Okay? So yung na-compute natin na protection fuse, ampere fuse is 15 amperes sa circuit number 1. Number 2 and 3 is 20 amperes and 20 amperes. And then yung size ng wire, paki-input dito. And conduit, size ng conduit, paki-input dito. Okay? And then sa baba ng ating schedule of loads, dito natin ilalagay yung computation para din sa ating service entrance. For the total current load, meron tayong 28.2 amperes. With the 80% demand factors, meron tayong the rated value na 22.8 amperes. So thus, we will use 2 pieces ng ating minimum. Diba? Minimum na ating service entrance is 8 mm or number 8 copper wire or conductor wire at 20 mm conduit type. So this type of material depende na to sa ating designer. So RS RSC for rigid solid conduit, IMP in intermediate metal tube, PVC CP, yung ating PVC conduit pipe. Okay? So dito, meron tayong sample para dun sa ating naging illustrated problem. May sample estimate, cost estimate tayo dito. So yung ating ginamit, di ba, is TW kasi thermoplastic moisture resistant at 40 amperes. And then pasok siya, minimum ito siya ha. So kumbaga economical price. TW yung nagagamitin na type of wire. And then pasok siya kasi minimum at 40 amperes below. So yung ating mga amperes lang is nasa 20 and 15. So here, sample cost niya, cost estimate. Ano ko? Quantity, hindi cost estimate, quantity, sample quantity. So here. So note, the quantity of materials is subjected to change depending upon the area and the choice, kumbaga, site natin, kung anong area tayo, mas mura sa Manila. So iba naman din sa area natin. And the choice of the designer, engineer, kung anong gagamitin mong materials. For open wiring installation, conduit pipe can be changed to split knobs or PDX wires. So dito nagtatapos yung ating sample illustration or sample problem para sa ating electrical wiring system. Next video, meron tayong sample for much complex electrical wiring system. Kumbaga, meron na tayong aircon na i-consider. Okay? See you at the next video.